Today we will look into part of speech training for a sentence. So we have been given two metrics. First one is transition probability matrix, where when you transition from one part of speech to another, so this is the probability matrix that has been provided. For instance, if you move from one model to another, what is the probability from model to noun? Yeah, and here we have emission probability matrix. This is with respect to words. So probability of the word he given it is a model is 0. Probability of the word he given it is a noun is 0. Probability of a word given it is a verb is 0. Probability of he given it is a personal pronoun is 1. So we have two metrics, transition matrix and emission probability matrix. Now we have to pause tag the sentence he will fight. So yeah, so here if you see, first of all we will try to mark what the pause tagging looks like for this word. So here if you see he, if we look at this table, he, we can say okay, this is 0, this is 0, this is 0, and this is again 0. So he, it appears to be only PRP. So it looks like it's just a personal pronoun. Now again if we look at will, so from this table we can see will, it is a model, and will is also a noun. So we will write under this MD, and we will also now write noun. Now if we look at the word fight, so fight, it is noun and verb. So it could be a noun, it could be a verb. So now we have to figure out the right pause tag, whether we have to choose one from here and one from here. This is already one, like okay. So how do we do this with respect to the tables that have been provided? So first of all, what we have to check is this word he is at the start of the sentence. So what you have to do is you will write it in terms of queries. You can say like where you want to reach the word he. You put something like this and write the word he that you want. Okay, so initially you want start of the sentence, then there should be personal pronoun, and you want to reach the word he. So how do we calculate it with respect to these two tables? We do it like probability of he given PRP. Probability of he given PRP, that it is a personal pronoun, multiplied by probability of personal pronoun given start of the sentence. Okay, the probability of PRP given start of the sentence. So these two probabilities now we have to check in these two tables. So probability of he given start of the sentence, probability of he given it is a PRP, so which is 1, multiplied by probability of PRP at the start of the sentence. Probability of PRP at the start of the sentence, it is 0.08. Okay, so this value becomes 0.08. Okay, so this probability we have calculated, and because of the space reasons we will just write it here, 0.08. Okay, now we can get rid of this part. Okay, so now we will reach the word, will. Now will has, it could be either MD or NN, but the previous state was PRP. Now the word that you want to reach is will. From where you want to reach it, let's suppose assuming the first one, MD model, and the previous state, so no need for like arrow like this, we will just say PRP. Okay, now probability of the word will given it is a model. Okay, so probability of the word will given it is a model, it is 0.8 into probability of model given PRP. So probability of MD given PRP is 0.08. So if we do this, along with this, what we have to do is see this state it was dependent on the previous word, so we have to also multiply the probability of the previous state of the previous word, so which is again 0.08, and this becomes 0.00512. Okay, so again we can write so obviously for this we will get 2, so first one we are writing as 0.00512. okay, so this was for PRP, this is for MD. Okay, now again we will delete this part and we'll move further. Okay, here now we will choose this one. Again the previous state was PRP, we are going towards NN, word that we want is will. Okay, so now we need to multiply these probabilities. So probability of will given NN, probability of will given NN is 0.2 multiplied by probability of NN given PRP. Probability of NN given PRP is 0.02. Again you have to multiply by the previous probability of this state, that means so it is again into 0.08, and this value comes out to be 0.00032. Okay, so again the second value we can write here, so 0.00032, and this is for NN. Okay, now if we have to choose the higher value, so obviously this is higher and this is lower, so this part can be avoided, so that means it is not a